Hello, everybody. We're going to get started with a training today. I'm just waiting for all the attendees to show up. So just hold on. We'll just be getting going in a minute or two. Just going to wait one more minute, see if anybody else joins us. Yeah, we got a couple more people hopping on. Okay, I think we will go ahead and get started. Welcome to Getting Started with Kubernetes, a Rancher Labs training. Really excited to present material for you guys today. Have about an hour together. Just going to introduce myself and my two teammates. My name is Matthew Shear. I'm a community advocate. I'll be helping to host today's training. If you have any questions, follow the training. Feel free to reach out to any one of us. My email there is matthew@rancher.com. And we will be posting this recording on YouTube and the website. Our solutions architect today is Jason Greathouse. He'll be going through the demo, answering questions, and Hussein will be handling our chat. So this is really interactive training. If you guys have questions, please do ask them, and we will not leave until everything is answered. So leading right into our goals for today. This is, again, a technical introduction to Kubernetes. We'll be using slides. We'll be presenting material to you guys, but really this is going to be demo heavy, and Jason will be handling our demo. So you'll get kind of a hands-on experience with Kubernetes via Rancher. And again, ask questions. We will pause what we're doing if something does not make sense. This is really for everyone to leave here knowing more about Kubernetes and feeling they have a good solid introduction to the material. Again, this training is going to be focused on Kubernetes. So if you've never used Rancher before, we will go through it a little bit, but this is a more Kubernetes heavy training. We have Rancher trainings every month. The next one is on March 8th, and you can sign up there. They're also free. And you can get your sort of basic concepts and understanding of a Rancher there. But if something doesn't make sense regarding Rancher, you please do ask so you don't get lost. More materials, just to give you a hand, more resources. Our docs are often updated. docs.rancher.com/rancher will get you to the overall Rancher documentation, and then the Kubernetes section is very robust, and you can have it open with you as we go through the training, and ask questions as you're reading and watching, or refer to it later. Also, our forums are a fantastic resource, very interactive. We have Rancher employees monitoring and answering questions. Sebastian is awesome. He's there all the time, helping people out. Forums.rancher.com. It's free. Please use it. And we also have our private beta group for Rancher 2.0 beta, which is coming out in a week. And all the questions about beta are there too. So if you want to join that, just let me know. Email me at matthew@rancher.com and I'll get you added. And so start to get into the material. We often get the question, well, why Rancher and Kubernetes? Why not just Rancher? Why not just Kubernetes? So I'm going to give a little opening to this question, and Jason will go more in depth, and we'll be able to answer more as we go along. But the main reason, several main reasons are, one, if you've ever tried to get Kubernetes started yourself, like it can be, especially when you're just beginning, it can be pretty challenging. And Rancher makes it, really easy. You get Rancher started, You spin up a Kubernetes environment and get containers to run Kubernetes, all in Rancher. It makes it a lot easier because you just get to interact with the Rancher UI, which is, clicks and buttons. So it makes it a lot simpler. And secondly, the system allows for automatic, updates of Kubernetes. So instead of having to do your own update of Kubernetes, you can just update with a click of a button. We do other kind of, upgrade management, and it's all in one place. And obviously, we have 24/7 support for those who need more robust help. And then the last reason is, we have Rancher 2.0 beta rolling out really soon, and Kubernetes is much more baked into the platform. And you'll find a lot more features and integrations there too. So there's all these other reasons. And if that doesn't make sense at this point, don't worry, we're just getting started. I'm going to hand this over to Jason, and he will help answer more questions and explain more about Kubernetes. So Jason, you ready to take it over?
Yeah, just leave that slide up for a minute. We're going to talk about some key topics here. First thing we're going to do is we're not going to go real heavy or really deep into this, but we're going to show you the basics of setting up Rancher server and then deploying Kubernetes through Rancher. Then we're going to set up kubectl so that you can run it on your own laptop or workstation. And then we'll get into some of the concepts and actually running some workloads in Kubernetes, including pods and deployments and services and config maps. Actually, we're not doing config maps today. We're going to do ingresses. So, all right, I think I'm ready if you want to switch over the control there.
Okay.
New. Give me just a second to get this organized. All right, can you see my screen?
I can see it.
All right. Okay, let's start out here. So the purpose of this training is meant to give you a good introduction to some of the Kubernetes concepts and patterns. It's by not any means a complete picture of all the things Kubernetes can do. We just want to give you a place to get started. So it is definitely beginner, zero level. We do hope that you have some experience with some of the Docker concepts, like what a container is, what an image is, and those things. So if you have some familiarity with the Docker commands and basic Docker concepts like that, this will go a whole lot. This will make a whole lot more sense for you. So let's get started. Full disclosure, I've prepared a few things ahead of time. I've set up a couple of VMs and pre-pulled some of the required images just to speed things up. If you'd like the gory details, all of the scripts and information that were used to set up my environment will be available, are available in a Git repo, and I'll share that link with you at the end of this training session. So to start with, I have a single Rancher server. Now I've pre-set up this Rancher server and started it because Rancher server takes a few minutes to initialize. But if I was doing it from scratch, it's pretty much as simple as this. Just docker run -d -p port 8080 Rancher server stable. The Rancher server container has everything you need in it to run a Rancher server. And that'll get you basically started here. In my window, you can see that I actually already have the Rancher server pulled up. One of the first things you're going to need to do when you start up the Rancher server is you're going to need to enable access control. I'm going to go ahead and disable my access control on my server and show you what that process looks like. Okay, so you'll notice that this little there's a little exclamation point here that says access control not configured, because that's because we really want you to enable access control on your server. And so we have several access control providers available. You can use your authentication provider of choice. There's Active Directory, Azure AD, GitHub. In our case, we're going to use the local provider, which is just setting up basic users and in the local Rancher database. So I'm going to go ahead and set myself up a user and set a password and enable access control. All right, now that we have access control set up, let's go ahead, and first thing we need to do is create a Rancher environment. So the Rancher environment is equivalent of the Kubernetes cluster, because that's what it's going to be. It's a dedicated set of nodes and resources for that particular cluster. Let's go ahead and add an environment. And we'll give it a name. Since we're doing K8s, we'll call it K8s. And when you set up a new environment, you have the option to pick a various different orchestration providers. And today we're doing Kubernetes, so of course I'm going to use Kubernetes. And at this time, you can also add users later, but we could add more users and groups to give access to this particular environment. So we'll go ahead and create that. And we can see that now in our environments list, we have a new environment called K8, the one I just created. We'll select that. And we'll see that it's a Kubernetes environment, and it's waiting to add some hosts. So let's go ahead and add a host, or 3. So I went to infrastructure, I went to the hosts menu item, and I'm going to go ahead and say, I'm going to show some system, and I'm going to say add host. Now there's 2 main ways to add host agents to your system. Very popular is to use the cloud providers. We provide the ability to launch VMs in your cloud provider of choice. You just select one of these cloud providers, like for example, Azure here. You put in your username, your credentials, and give it some information about where you want these VMs to be hosted. You know, what region, what AMI, or what image to use, those sorts of things. And in about 10 minutes, you'll have a fully functioning Rancher environment all ready to go. Now, no one wants to wait 10 minutes for that to happen, so I'm going to do the other method of adding a host, which is the custom method. And doing this custom method is as simple as copying and pasting this Docker run command into any Linux node that has Docker installed. This will, with this unique URL, will add any host that you run this command on to this Rancher environment. So I have 3 agent nodes already set up, so I'm going to go ahead and copy and paste those onto the agent nodes. Yep, please paste that. Go ahead and do this one. And we'll do agent number 3. And so if we, the demo gods smile upon us, we should see here in a second. Back to hosts, we can see that the hosts are already starting to start up. And you'll notice that they are launching a whole bunch of services and containers. Well, these are the services and containers that are required to run a Rancher hosts and also Kubernetes. While we're waiting for that to start up, let me tell you a little bit about Rancher's distribution of Kubernetes. Our distribution of Kubernetes is 100% upstream Kubernetes. It's Cloud Native Computing Foundation certified. What does that mean? That means if it works in Kubernetes, it'll work here. It also means the other way. If you decide that you want to take your ball and go home, you won't want to use Rancher anymore, you can just take your workloads. They'll be portable to any standard version of Kubernetes. So why would you want to use Rancher? Well, we provide one-click upgrade to new Kubernetes versions. We maintain the services that are required to run Rancher and Kubernetes for you 24 hours a day, 7 days a week. If you had a node failure, we would go and reschedule those services onto another node for you. You don't have to, no interaction on your part is required. We also provide redundant etcd with backups every 15 minutes with 24-hour retention for you, automatically set up. And we also provide centralized authentication with your choice of providers that we showed earlier. AD, GitHub, LDAP, your choice. And this is almost done starting up. As soon as all this stuff kind of goes green, our Kubernetes environment will be ready. So in addition to just installing the services that are required for Kubernetes to run, we also actually install a few extras just to make it more useful. So we also provide the open source Kubernetes dashboard, so you can have a GUI implementation to kind of look in on what your workloads are, what your pods are doing, things like that. We also provide a tiller installation for your Helm catalog, so you can launch Helm catalogs. We're not going to go deep into catalogs during this training, but you should know that that's something that's available. And we also provide some basic monitoring for the health of your cluster with Heapster and Grafana. And it looks like all the Kubernetes stuff is done, so let's go ahead and take a look at what we provide. So like I said earlier, the dashboard is available. I hope this is launched at this point. And you can go ahead and take a look at this, and this is just the open source dashboard, so you can see different workloads that are running, your different namespaces, things like that. We also provide a really convenient CLI for the Kubernetes, for the kubectl command, so you can run that from within the browser here. So kubectl get nodes. And we can see our nodes are all ready to go. But most people aren't going to want to go into the browser to use the CLI. What most people are going to want to do is they want to use kubectl from their laptop or workstation. So in order to do that, we can generate a configuration for you. And you just need to copy this configuration and put this in, the easiest thing to do is to put it in your home kubeconfig file. I already have this file here, so I'm going to go ahead and paste that in here, I hope. All right, and with a little bit of luck here, CTL get nodes. We should now be hooked up to our Kubernetes environment. Uh-oh. Well, yay demo. So I do have a confession to make. I'm normally a Linux user, and this GoToMeeting webinar does not work on Linux. So I've just tried to quickly convert over here. So let me see if my file is correct and I didn't mess this up somehow. It looks correct. Awesome. Love live demos. Used it. Let's see here. And I apologize for this.
Hey, John, maybe Hussein says you should try pointing to the kube config using kubeconfig.
Let me try that. I may have a conflicting configuration going on here.
Yeah.
If I could spell. Now I'm a little flustered. Config.
That's okay, it's live. All good.
Yep. All right.
No, you might want to add option --kubeconfig with kubectl and point to the kubeconfig.
Oh, kubec. I'm sorry.
Yeah.
And it was
--kubeconfig, not config.
Oh, kubeconfig. Okay.
Yeah. One word.
All right. Awesome. Thanks for the hand there, getting that set up.
No problem.
Okay, where was I? All right, so we got our kube control CTL set up, and well, let's just jump in and run something here. So, oops. So kubectl has a helper command to get you started called run. Now the run command is a lot like the Docker run command, and it's going to create some of the lower level objects and abstractions required to get things running in Kubernetes. So let's call this game. That's going to be the name of our run command here, of our deployment. And image equals jgreat 2048 0.0.1 version. We're going to give it a port, if I could spell port correctly, port of 80. And we're going to want to run more than one of these because we think it's going to be really popular. So replicas equals 3. And let me go and make this other screen over here a little bit more interesting. Let's hide the system stuff. And you should see that starting up, you can see that we're actually starting up. These are pods. We'll get into what these things mean here in a second. And the containers have all started up, and it's actually deployed our game to our Kubernetes cluster. So what did this do? What did doing run do? Well, kubectl, grab that, get all. All right, so this actually created a number of different objects for us. The first thing it created was it actually created an object called a deployment. That deployment created, and we'll get more into what these objects actually are in a little bit, but I'm just going to point out what it created to start out with. So it created an object called deployment. The deployment actually creates an object called replica set, and the replica set is what actually creates our pods and containers. So let's start at the bottom and we'll work our way back up to the top. So we'll start at the smallest thing, pods. What are pods? Pods are the smallest unit that can be deployed in Kubernetes. They consist of one or more containers that are scheduled together on the same node. Each pod is given a unique IP address. So this means that all the containers in a pod actually share that IP address, so that the workloads in different containers in a pod can talk to each other via localhost. If this is kind of confusing, there's a lot of power in this setup, the ability to separate your workloads into different containers and have them being able to share the same network address space. But to be honest, most of the time, one pod is going to equal one container. And so if this is confusing, don't worry too much about it. For the sake of this demo, all of our pods will only have one container. So think of a pod as just a container. So let's take a look at our pods. So kubectl, along with some options like kubectl, has kind of a standard format for how you run it. First thing you do is you do kubectl, you do an action, and then you do the object that you want to do the action on. So in this case, we want to get the pod objects. And it shows that we have 3 pods running. You'll notice that they have the stat. You can see the status here of running. You can see about how old they are. They're about 2 minutes old, and that they have one container, and that container is ready. Now you'll notice that they get started up with some really kind of weird randomized names. Well, they're not completely random because they actually follow a little bit of a pattern here. So we have our deployment game up here, and we have which creates a replica set, which has the name game from our deployment, but also creates a unique identifier for that replica set. And then each of the pods under that replica set have the name game, they have the replica set ID, and then they have their own unique identifier for that pod. So that's how these things are named. All right, let's get a little bit more information about a pod. So we're going to go ahead, instead of get, we're going to do a describe. And we're going to say we want to describe an object pod, and then we'll get a specific pod here. All right, this is going to give us a little bit of output here. And it gives us some information about the name. It talks about what node it happens to be running on. it talks about the labels that are assigned to this pod. And we'll get a little bit more into labels later when I show you manifests, and talk about why labels are important to Kubernetes. We get the status, we get the IP address, get a bunch of information about a pod, but really kind of the most interesting thing for me about this display is the events down here. Should your pods fail to launch for some reason, let's say you might have accidentally typoed the image name and it can't find that image name. Where you're going to find that information about what went wrong is in this events list down here. Now down here we see that we have for our polled event and polling event that we successfully polled this image because it's an image that exists out on Docker Hub. It was able to get to it. If I had typoed this, if I had misspelled something, we would get a type event of error, and we would see something like could not find this image. So when you're troubleshooting why your pods aren't working or why they keep restarting or whatever, a good place to start is with this describe output. All right, so now we know a little bit more about our pod. There's some other things we can do with a pod. Just like Docker, we can run an exec command on a pod and run either an arbitrary shell command, or we can go ahead and get a shell into the pod to take a look around and run things interactively within it. So go ahead and do this. We're going to do exec. We're going to give it the interactive terminal command just as you would with a Docker exec. We're going to give it the name of the pod we want to execute on, and then we'll give it a command. So in this case, I want to run shell. And now we have an interactive terminal on this pod.
Hey,
so we can look around. Yes.
This is Matthew. I'm just going to stop you for 1 second because John Sims is telling us that the screen appears frozen. So would you just stop sharing your screen for a moment and then reshare it? I think that might refresh the whole thing and we'll be good to go.
Sure.
Awesome.
Has that helped at all?
Just keep going and we'll see if John says it's working or not.
Did it update when I updated my shell?
Let's see. Why don't you try? Oh, other people are saying it's looking good, so I think you can just keep going, and maybe John can.
Maybe it's just his connection then.
Yeah.
All right. Great. Okay, so right now we have a shell in the pod. We can go look around. We can edit files if we wanted to. Along with normal. If you're running Docker anywhere, if you start editing files in your container and that container goes away, those edits will go away. So this is just a good way to do troubleshooting. So we'll exit out of that. Another useful feature that you can do is you can get the logs for a particular pod. So let's go ahead and do that. I'm going to do logs just like you would with the Docker command, and a -f to follow that log. And the only thing this thing is logged is a little bit about, it says it started the 2048 game and it has some credits for the person who wrote this particular game. So, all right, let's move up the stack a little bit and let's talk about what actually created those containers, which is the replica set. So let's get, if I spelled that correctly. All right, perfect. All right, so replica sets. Replica sets are an object that is used by Kubernetes to manage the life cycle and scale replicas of a pod. Why would you use replica sets instead of just saying, hey, I want a pod? So you could imperatively just say, I want pod 1, I want game pod 2, I want game pod 3, and run individual commands and individual to spin up these 3 commands. But the real power of Kubernetes is being able to do these types of things in a declarative fashion. So what a replica set allows you to do is it allows you to declare, I want game pods, and I want you to make sure that there are 3 of them running at all times. That's really what the replica set does. You might have heard, if you've done any little bit of stuff in Kubernetes, that there are other ways of actually scheduling pods besides just using a replica set and creating replicas, creating exact replicas of the pods. There are things like daemon sets and scale sets and jobs and such. Those are whole topics on their own. like you to know that those are things that are out there that you can do, but we're not going to go through them right now. We're trying to keep this really simple and real low level just to get you started. All right. So the funny thing about replica sets is, yes, it's a thing in here, but in recent versions of Kubernetes, you don't actually interact with replica sets. What you really interact with is deployments, and that's why the run command creates a deployment. So let's see here. Git deployment. All right, so we have our deployment game, and you'll notice that the output for the replica set and the deployment are pretty similar to each other. You have the desired, you have them current, what are up to date, which is an addition, and you have how many are available and what the age of your deployments are. The purpose of a deployment object is really to manage the release of new versions of your applications. So Kubernetes can track the history of deployments and allow you to roll back to previous deployments if you need to. And it gives you the option to basically save previous versions so that, God forbid you have a bug in your code and yes, it passed your test, but there's actually an issue in production. You have an easy way to be able to roll back to previous versions of your application. All right. Before we get into to show you how that works, I want to introduce another concept that's really important to Kubernetes, and that's manifests. So far, I've showed you creating resources with some one-off commands like run, but the real strength of Kubernetes, like I said earlier, is that you can create resources in a declarative format. And so you can do this by creating and applying manifests. So every object in Kubernetes can be described with a YAML document. And let me show you what that kind of looks like. So we get our deployment game, and we're going to give this another option called output -o, and we'll say YAML. And what this will do is it'll spit out a whole bunch of stuff, which is a YAML document. This YAML document gives you, this YAML document could be used to recreate your deployment as is. But this YAML document actually has a bunch of extra information in it that's not really needed to start up a new deployment. This has a whole bunch of information about what the current status, for example, this whole status block down here is not necessary for starting up a new deployment, but is information about what's currently deployed what's the current status of the deployment in Kubernetes. So if we don't need all this information, what's a good way to generate a manifest so that we can use it? Let's go ahead, and we're going to go ahead and kind of start over here. So I'm going to actually delete the current deployment and show you how to create a manifest from scratch. And then we're going to apply that manifest and relaunch our deployment as it is. So we're going to delete the deployment of game. Give it a second, and you can see over here in our other window that these things are starting to be torn down. All right, so now we don't have any more deployments. Do a git deploy, and Kubernetes has some shortcuts for, instead of typing out deployment all the way, you can type deploy instead of pods, you can say PO, things like that. So we didn't find any deployments existing. So let's go ahead and create the YAML manifest for this deployment. I'm going to switch directories real quick here. Training and into my game. Oh, let me switch to this shell. This shell should work. Oh, that's just a mess, isn't it? I'm sorry about that. All right. All right, we have some deployments in there. We have some manifests in there. That's great. So let's create a new deployment. All right, let's scroll back up until we find our run command. So we can take our run command and we can add just a couple extra commands to this. We can tell it to do a dry run, which says, don't actually create any objects, just pretend like you're going to. And then we're going to go ahead and say, I want you to, instead of actually, trying to create this object, I want you to output it as a YAML file. And you can see that this is actually the minimum manifest that you need to start up that deployment. You can see that it contains a lot less extra metadata and status that just aren't needed for starting up a new deployment. So this makes it a little bit easier to start out with and read. And what we have going on here in this manifest, first thing you'll notice the API version. And don't be scared by the fact that it says beta. Like a whole lot of other Google products, for whatever reason, beta pretty much means production to Google. Now, there are some alpha extensions and alpha versions that explicitly need to be enabled in Kubernetes in order to use them. And those are really the things that are in testing. By the time API extension gets to beta, it's pretty much ready to go in prime time. Everybody's pretty much using it. So then we have the kind. So this is the kind of object that is in our manifest here, which is a deployment. We have a little bit of metadata. Like I said earlier, Kubernetes puts a lot of importance on labels. It uses labels as a selector. So it uses labels to basically associate objects with one another. So the way it's going to associate the deployment with, you remember that it created the replica set, is that it's going to say, and down here in this metadata, it's going to say, in the selector here, when we actually start defining what the object is, that it's going to use the label of run equals game. And so it's going to say that when my associated replica set is any replica set that has that label of run equals game. And then the replica set, in order to associate to the particular pods, is also going to use that label because that label will get passed down to the pods. So it uses a selector to say that any pods that have run equals game are mine. Okay, hopefully that wasn't too terribly confusing. So now we get down into the spec, and the spec is actually where we define the things that make this for this particular object. So we define the replicas here. We want a 3. We get down into the template, and the template is actually the template for creating the pod. So we're going to have, in the pods metadata, again, we're going to have a label, game equals run, like I said earlier. And then it has a spec of containers that are inside the pod. And one of the containers that we're going to be running is going to have the image of jgreat2048 with the tag of 0.0.1. And we have the name, and we also have the port of that this particular workload is running on. So let's go ahead and get that out to a file. Let's see, game deployment. All right, so we echoed that out to a file. And if we cat that file, we can see that file now contains the same thing that command spit out. All right, so now that we have that in a file, what can we do with this? Well, we can now save this. We can commit it to a Git repo. So now that we have our infrastructure as code, and then if we want to, we could update this and apply new versions of it. So let's go ahead and run our deployment with this initial version, and let's get it out there. So how do we do that? So kube, let's go back to our kubectl command. And we are going to go ahead, and the nice thing about Kubernetes is that you can just say apply and provide it as a file, and any objects that are in that file are going to be created. So we do game deployment, and Kubernetes has gone ahead and created that deployment for us. All right. So now we have a new version of our application, and we want to go ahead and update the running version. How do we do that? So let's go ahead and edit our manifest file. So vim, and that's going to be game deployment. So we can go in here, and I just want to update this to a newer version. We have a new container available for this. So we're going to go ahead and change that to 0.0.2. We're going to save our file. And then we're going to go ahead and just apply this file again. And this is actually going to create a new deployment. It's going to update our deployment. The deployment's going to create a new replica set, and that replica set is going to create a new set of containers for us. And you can see all that happened really quickly here. So now that we have that new deployment, let's go take a quick look at it. Git deploy. We can see that it's up and running and everything looks like it's healthy and available. So I talked a little bit earlier that the whole purpose of deployments is to manage the versions of your application. So let's say we did deploy this 0.0.2, which is what we have. We can actually describe this deployment. We can see that. Deploy game. And we can see that we're on revision 2 of our deployment, and we can see that the pod template says that our image is now 0.0.2. And you can see some information about what it was doing with the deployment. Okay, so now we have 0.0.2 running. Let's say that there's a bug in 0.0.2 and we really need to roll this back. Well, Kubernetes gives us the ability to do that really easily. So let's go take a look at the history of what Kubernetes calls rollouts. So rollout history of deployments game. We can see that we have 2 revisions of our game deployments, and it will actually track revisions down the board for you. So how do we know which revision is which? Well, we can go ahead and if we do rollout history game and then we specify a revision, let's say 1, we can get the details of what that pod template for that revision looked like. And so let's say we want to roll back to that previous version. If you just want to go back to the previous version, it's actually it's really simple. So we're going to say rollout undo deployment game, and this is going to actually relaunch our previous version that it saved. So it remembered what our previous pod template was. It remembered, all the information about it, and it goes ahead and relaunches that, and then reassociates it with all of the various services and other objects that might be associated to this deployment. So we can check the status of that. So if we describe deployment game, and what it actually does is you might notice that we've gone to revision 3 because we don't actually go back. What we do is just we reapply the previous version. So we actually go forward and revision. Hopefully that's not too confusing. But now we're back to running our 0.0.1 version. Okay, so now that we have our deployment and we have our services, or not our services, we have our deployment ready, we have our pods running, we have a workload running in Kubernetes. Now we need to be able to do something with it. We need to be able to access it. So let's talk a little bit about service discovery. So by default, everything in a Kubernetes cluster can talk to each other over the cluster overlay network. But all the pods get random addresses and names. So how do you find and connect to these workloads? Well, this is where the services object comes in. So a service provides 2 main functions. It provides a consistent DNS and IP address endpoint for communicating between workloads. And it also provides load balancing for your connection across your pods. So let's show how this works a little bit. Let's go ahead and launch another workload. So let's get over to apply, and instead of applying another game, we're going to go ahead and apply a simple shell workload, if I can spell. Shell deployment. So we'll go ahead and create a new workload, and you can see over in our Rancher instance here that we now have a new set of pods called shell. And I'm going to go ahead and exec into that shell.
Hey, Jason.
Yes.
This is Matthew. I just want to interrupt you for 1 second because we have a request from one of the attendees to show the Kubernetes dashboard within Rancher. Is that possible to do while you're working?
Yeah, it doesn't refresh for you automatically, I don't think. But let me see. I don't actually use it that often, to be honest. I'm really more of a command line guy if I can get away with it. So let's just see pods here. Hope this is okay. We'll see if that refreshes automatically when I start changing things. I'm not exactly sure, to be honest. So, all right, where was I? Okay, I was going to go ahead and we launched our shell. I was going to go ahead and exec into that shell, into that pod. So exec -it, and that was shell. Oh, let me do a get pods, so I can get the name of that pod. And then exec it, the name of the pod, and the command I want to run, which is bash. All right, so from in this shell, I could ping. If I knew the name of one of these, it's already existing, I could actually, but this random name of one of these pods, I could actually ping this pod from my other workload. But that's not a very friendly way to interact with it. What I actually need is kind of a consistent endpoint. So, and I practice this on a different, so we're gonna go ahead and create a service. So cd game, and I'll show you kind of what that provides. Get back here, let me copy paste my command here. Okay, so we have a service. Let me show you what that service manifest looks like first before I go and apply it. So game-service YAML. All right, the service manifest is relatively simple. You can see it has a very similar format. It's a YAML file. It's a very similar format to the deployments manifest I showed you earlier, but you notice a couple differences. So services have been around a long time, so it's actually a proper V1 version of the API. Again, the kind is service instead of manifest. And you can see that this service manifest is also going to use the labels. We're going to create the run equals game label and provide that as a selector for this service. So that when we create this service, any of the pods that have this label of run equals game will, this service will route and load balance across those pods. So that's how they associate to each other. And this service is listening on port 80, protocol TCP, and it's forwarding traffic to port 80 on those pods. So let's go ahead and apply that service. Okay. Apply. Game service. Hang on a second. Yes. Okay. Apply -f game service. If I could type. Yay. Okay, so we applied the service. We can go ahead and take a look at this service. Do a get service I did not spell that correctly, so it's going to get mad at me. Okay, we can see that Kubernetes has a service running, but also now our game has a service running. By default, services have a cluster IP, which means it's basically an internal to Kubernetes load balancer. There are some other types of services that you can launch, including a node port, and you can launch a load balancer type service, which is actually going to create load balancers if you're using a cloud provider like Amazon AWS, excuse me, then that's available. But we're not really going to go into that right now. We're just going to talk about how you connect to a workload within the Kubernetes cluster. So that service is available. So what did that actually do? Let's get back over to our shell. So now, instead of having to know the name of a particular pod to get to, the service actually created some DNS for me so that I can have a predictable name to connect to other workloads. So if I do a curl, because I know it's an HTTP workload, and I do a curl and I give it the name game, because that was the name of our service, we can see that we get a response from our game pods, all this HTML here. This shortcut of game works when services are within the same namespace, and I briefly went over that a little bit earlier. Namespaces are just a logical concept for separating out services and workloads into, well, separate namespaces, so that you can have, for example, you can have a namespace of default game, and then I could have another namespace of JGreat, and then have a game service also under that of the same name. So in order to fully qualify, if you were talking outside of this namespace to some other service, the fully qualified name to connect to a service is the name of your service, the name of the namespace, in this case default.svc.cluster.local. And you can see that also goes to our load balance, our service, which load balances across the various game pods for us. All right, so that's all fine and dandy. But what happens when you want to publish this game to the world? Because now it's available within the Kubernetes cluster. This is where the concept of ingress happens. So what are ingresses? Well, ingresses are layer 7 capable proxy services. Rancher comes with a built-in ingress that's based upon HA proxy. There are other ingress controllers available. One of the most popular ones is one based off of Nginx. But for right now, I'm just going to show you the built-in one that comes with Rancher. So let's start out by taking a look at the manifest for this ingress. So we're going to go ahead and cat our game-ingress. And this one's going to be a little bit different. Again, we have, this is a beta API version. We have the kind of ingress, that's what kind of object it is. We have a metadata, some metadata. We have the name of game, that's the name of this ingress. And then we have an annotation that's specifically to our Rancher configuration. And the details on these annotations are available in the documentation at rancher.com. So, but this one's just saying that, hey, I want to run a copy of this ingress on each one of my Kubernetes nodes. I want to schedule it globally, and that's kind of a Rancher concept. So the Kubernetes equivalent of that would be like running it as a daemon set. So so let's get down into what we're actually doing to define this. Now, I said this was a layer 7, which means that you can do things like it's capable of doing things like host names and also path redirection, a lot like HA proxy or Nginx is capable of doing when you put them into a proxy mode. So we can have multiple services that are behind an ingress and route traffic to those to different backends based upon things like, in this case, I have a host name that I've set up, and I could even have multiple backends for this host name. Like I could have a path of default, and I could have a path of like game2 going to a different service. Weirdly enough, this doesn't, for some reason, and I don't know why they don't do this, but this doesn't follow the whole selector thing of using a selector to use it. So we actually give it the service name of game instead of using like a selector label. I'm not sure why that is. And we also give it the port of what the port that service is running on, which is 80. So we'll go ahead and launch this ingress and kind of show you that it works. All right, let's see here. So kube control, and just like all the other things that since we're just applying a configuration file, we just use the apply, or a manifest, I mean. Kube control apply -f and game -ingress. All right, it created our ingress. Now I can get some information about our ingress. So if we switch back over real quick, we'll see that we're actually launching some containers for those ingresses across our cluster. And we should see in here that we have an ingress called game, and you can see a little bit of information about that. Let me show you what that looks like in the kube control. CTL, if I do a get and I do ingress, and I'm going to do a -o wide format to get a little bit more information about this. And what we see here is that this is a host-based ingress, and it's listening on game.jgreat.me, so it's only going to accept traffic for that host name. And it is available on these various IP addresses. Now, I've done a little bit of work ahead of time, and I've set up a DNS. I've set up a DNS round robin, a record round robin for these IP addresses to this host name ahead of time, so that I could show that this routes correctly. So let's go and see if we didn't screw this up. Hey, so we have our 2048 game. Awesome. So that is the extent of the Kubernetes basics that I wanted to show off today. I hope that this has been informative and give you a little bit of an example of that it's not impossible, it's not that difficult to get started with Kubernetes and to start with some basic things. Kubernetes has a lot of power and a lot of options, so there is you can get extremely complex and with some of your configurations. But if you start with simple stateless applications, getting your foot into getting yourself into the water is not that difficult. So I guess at this point we can find out if there's any questions or anything else that we might want to show off.
Yeah, let's see if there's any more questions from any attendees. Just type in your questions. We'll see if Jason and Hussein can answer before. There's a couple more resources I want to show you guys before we go. But if anybody has questions, let us know right now. And just wait a minute, see if any new questions pop up. So Jason Conwar asks, is there a way to use VIP instead of a DNS name?
To use a VIP instead of a DNS name. Now, there are tons of ways to do this. So there are some add-ons that will actually create the DNS for you. There is a Kubernetes extension for like Route 53 and other various common available APIs to DNS to create these things automatically when you create ingresses and services and such. One of the more common ways to do it is to actually put a load balancer in front of your like an ELB or maybe a simple just layer 4 load balancer in front of your Kubernetes cluster just to route traffic in on port 443 and 80 and then allow the ingress to do all the actual routing to the various services. So there are a number of ways you can get just a single IP address available to your external to do externally access workloads within Kubernetes. Hopefully
Awesome.
that answered the question.
Yeah, Conwar, let us know. And so we got a couple more from Will. He asked, can you briefly describe the differences between the Rancher 1.6 and Rancher 2.0? I know there's a lot, but do you want to just highlight
Oh, goodness.
in regards to Kubernetes?
So Rancher 1.6 and Rancher 2.0. So Rancher 1.6, when we talk, well, I'll say specifically around Kubernetes. So when we talk about Kubernetes and Rancher 1.6, what we're really talking about is giving you Kubernetes. We're not providing a whole lot of hand-holding or like the nice GUI you get when if you use the cattle orchestration, where you can go ahead and create stacks and services within the GUI. Initially, what our customers wanted is Kubernetes is hard. It requires a lot of services to set up. If you want to see how hard it is, go check out Kubernetes the Hard Way by Kelsey Hightower. It's a great introduction. It's not the easiest way at all to set up Kubernetes, but it gives you an idea of the internals of Kubernetes and what it takes to actually set up a cluster. So you saw how easy it was for me to go ahead and create an environment. I mean, I did that live, and for Rancher to get Kubernetes up and running for me to make it useful. Now, there's a whole bunch of options and customizations you can get into when you're talking about Kubernetes, but that's the point of 1.6, is to make Kubernetes possible and easy to start up. Now in 2.0, we want to take that to the next step. We're going to take that to the same level, it's the same easy level of abstraction that we have when you're talking cattle and Docker. We're going to take that to Rancher and Kubernetes in 2.0, so that realistically, your users may actually not know anything about Kubernetes, but they're still going to be able to run workloads and get themselves started. Whereas, and your power users are still going to be able to use Kubernetes and still going to be able to use kubectl and all the stuff underlying, just like the way we do with Docker and cattle under Rancher 1.6. So that's the goal of 2.0, is to make it even more accessible to not only the power users, not only your systems administrators, not only your engineers, but also like all of your developers and your QA team and all those other people who actually really want to run workloads in your environment. So I hope that's
Awesome.
that covers the question.
Awesome. Yeah, and Will, I'll just add that we have other resources to check out the difference between 1.6 and 2.0. The last online meetup that Shannon, co-founder, and Darren Shepard did are on YouTube, and they talk a lot about the differences, and we'll have more content coming up.
Yeah, you can check out the tech preview too there, give you a good idea of what it's going to look like and what it's going to be capable of. So we're getting closer. Super
sweet. Okay, one more question we have from Darlington. He asks, is there a good guide on installing Let's Encrypt certificates with Rancher Ingress?
Let's Encrypt certificates with Rancher Ingress. That is a good question. I have not actually done that. I would have to go do some research to find out if there is a guide to do that. I've not tried to integrate that. I know it's pretty easy to integrate the Kubernetes secret store, and I know we didn't get into that because it's a little bit of an advanced concept today, to integrate the Kubernetes secret store with the Rancher Ingress controller, so that you can get your certificates that way if you have static certificates already created. I would have to do some research on Let's Encrypt. I'm sorry.
Okay. Yeah, maybe we can do a little follow-up. I mean, we're going to be sending a follow-up email to everybody who's on here. We can try to answer that question. Or we might just need an advanced training, and we'll put it there.
Doing an advanced training sometime would be really helpful, where we can go into things like actual persistent data stores, talk about persistent volumes and claims, and talk about secrets and config maps and stuff like that, which are a little bit more, the things you will want to actually utilize when you start really stretching the power of Kubernetes.
Right. All right. Well, I think those are the last questions. So could you give me back, or I'm going to take back control just to go through a couple more resources for everybody.
Yeah.
Let's just zoom through these slides. So we mentioned at the beginning, the forum and the docs. We also have our Slack channel, which is really active at slack.rancher.io. It's free. And the channel is hashtag Kubernetes. We have a couple Rancher employees who monitor that and a bunch of community members. So you'll never be short of support to continue to ask questions. So check that great resource out. We want to thank everybody for the questions, for helping us, practice and make this class better. We have this every month, and there's been a lot of interest in what Rancher is doing with Kubernetes and in Kubernetes, and so we might have more of these each month. But one more resource I want to tell you about is the Deploying and Scaling Kubernetes with Rancher book by Vishal and Gurish. It is awesome. It came out last year. It's 60 pages, really in depth. So if you need to know more, that is, I think, the right next step. So check that out. It's free as well. And thanks so much, everybody. We will be posting this recording on YouTube, our website, and sending you a follow-up email.
All right. Before you go, can I share one quick thing?
Do it, Jason.
If you can give me back the control, where did that screen go? Real quick, share that screen. All right, do you see my screen again?
Yep.
All right, so if you're interested in any of the code that I use to spin up the servers, any of the manifests, just as some simple examples, it's available in my GitHub here. So GitHub, Great, Great, and it's K8-training. So it's all completely available if you want some demos, want some examples. So I'm done.
Awesome.
Thank you.
All right. Thanks, everybody.
All right, goodbye.